Okay, this is circuit 5 from Project 7 for Fun with Electronics. This is where we've got the voltage divider set up, and then we're putting an AC signal and measuring the whole thing and the divided voltage. So here's my circuit. I kept it off of the breadboard because we're going to be using high frequencies, and I didn't want the breadboard capacitance to mess with it. And right now we're inputting a 60 hertz square wave, and this is what shows up on the oscilloscope there. Kind of what you would expect. I've got the ratio of signal 2 to signal 1 here, and the peak-to-peaks of both of them. So right now we're seeing pretty much exactly half of the total voltage across one of the resistors, which is exactly what we'd expect. So let's turn it up to 1 kilohertz. So this is also pretty much exactly what we'd expect, nothing changed from 60 to 1K. Now let's go to 10 kilohertz. Now things are a little different. We're just seeing less, just a little bit less than half of the total voltage across one of the resistors. Also, if you look closely at this peak, the peak of the channel 2 is starting to shift to the right a little bit as we go, or add the higher frequency. So now I'm going to go up to 100K. Now we're seeing a lot less than half of the total voltage across one of the resistors. You can see it's like maybe 1/4, because we're getting 500 millivolts across one resistor, and then about 2 total. And you can see that the phase of channel 2 is even more to the right than it was at 10K. So it's acting like a low-pass filter. The higher frequency we go, the less signal we get at the output. And it's also kind of the fact that the peak is shifting a little bit to the right makes me think that, or that and the kind of low-pass filter behavior made me think, does the resistor have a little bit of inherent capacitance? And the answer is yes. I went to do a quick search on the web, and this is the physics stack exchange. I found this neat diagram, the hidden schematic of a real resistor, and it shows the series inductance and the kind of built-in capacitance of the resistor, which makes it act kind of like a low-pass filter at high frequencies. Most of the time, it's not a consideration, but it does have, like it's saying here, the capacitance, the self-resonant frequency, and at high enough frequencies, it has to be taken into account. So, a very cool circuit demonstrating the, I don't know if you would say flaws, but the non-ideal parameters, the non-ideal characteristics of real components. I'm going to turn it up to 1 megahertz just to see what happens. 1 megahertz. Yeah, now we're getting like nothing. I'm not sure I can even find a peak on the green. Well, it's kind of there. Yeah, very cool.